Hi all. In this set of examples, we will work with more than one variable for each problem. And in this first example, we have two variables, x and y, and we are asked to solve for y. The first step in this problem is to move anything with the variable that we're asked to solve for to one side and everything else to the other. Again, the goal is this. And so there's two options. I could start by moving negative 3y to the left by adding 3y, or I could move my 7xy term to the right by subtracting 7xy. I'm going to choose to add 3y. And I'll also add 2. And so I'm left with 7xy plus 3y is equal to 4x plus 2. Again, the reason that I did that is so that I could get anything with a y, any term I should say with a y, to one side and everything else to the other. This allows me to factor out y, and when I do, I'm left with y times the quantity 7x plus 3 is equal to 4x plus 2. Again, you can think of factoring out a y, pulling out a y, almost as the inverse of distribution. If I were to, working backwards, if I were to redistribute here, you'd see that we get 7xy plus 3y. But by factoring out a y, I can now divide by that quantity 7x plus 3, divide by that quantity 7x plus 3, and I've isolated y. I've solved for y. And so y is equal to 4x plus 2 over 7x plus 3. Now I know the temptation is probably there to cross out your x's. We'll talk more about why you cannot in class, but you cannot cross out those x's. I'd like to take a moment and talk about an alternate solution that is equivalent to this answer. And that alternate solution would result if I had gone the opposite direction. So in the first example, I added 2 to both sides. I added 3y to both sides. What if I had gone the other way? If I had subtracted 7xy and subtracted 4x, then I would have this. Let me change colors. I would have negative 2 minus 4x is equal to negative 3y minus 7xy. Again, I have all of my y terms over here. That's what I want. I'll factor out a y. I'm left with negative 3 minus 7x, and that equates to negative 2 minus 4x. I'll divide by negative 3 minus 7x, divide by negative 3 minus 7x, and here is my solution for y. Now, I mentioned that these are equal to each other, and they are. They don't look exactly the same, but they're equivalent. If you were to factor a negative 1 out of the numerator, you would get negative 1 times the quantity 2 plus 4x. And if you were to factor a negative 1 out of the denominator, you would get negative 1 times the quantity 3 plus 7x. Of course, we still have this, we're still dividing, and negative 1 over negative 1 reduces to 1. In that instance, you can reduce that, and you are left with, there should have been an x here, I apologize, you're left with 2 plus 4x over 3 plus 7x, which matches this. They're equivalent. In the next example, we are asked to solve for r. And now we've got, let's see, 1, 2, 3, 4 different variables, and we're asked to solve for r. This is, I'd say, one step more complicated than the previous example. We need to get this r out of our denominator. And to do that, we can multiply by the entire quantity r plus 3. Multiply the right by r plus 3. Well, we've got to do the same to the left. And so what I have now is m r plus 3m, that comes from distributing my m, is equal to RP minus A. Now let's take a moment and talk about that. I multiplied by the quantity r plus 3. This you should recognize is also a quantity, and so I have a quantity, a binomial in this case, multiplied by a binomial, and then divided by a binomial, but r plus 3 over r plus 3 reduces to 1, which means that on the right-hand side we're just left with rp minus a. At this point, if we pause for a moment, you should feel a little more comfortable. That first step was maybe not obvious. At this point, you should be feeling a little better about next steps. If I'm solving for r, I need any term with an r on one side and everything else to the other, as in the previous example. I will, in this case, subtract rp and subtract 3m, and that puts me here. So mr minus rp is equal to negative a minus 3m. Of course, I've got everything with an r on one side. I can factor out my r. And last but not least, I can divide by that quantity m minus p. And I've got r, that reduces to 1. I have r equates to negative a minus 3m over m minus p. Now, back here for just a moment. As in the previous example, if I had reversed the order and moved terms to different sides, then I would have gotten the alternate solution, a plus 3m over p minus m. Once again, these are equal to each other. One is not better than the other. Notice the sign of all four of these terms is opposite here, because we factored a negative 1 out of the numerator and the denominator, and of course negative 1 divided by negative 1 reduces to 1. So solution A, solution B. We've solved for r. We've isolated r. Last example, and part of the reason that I wanted to work this problem is because we have these primes, and if you've ever taken a calculus course, you might be thinking derivative. Well, in this case, we're recognizing, we're not doing a calculus problem here. We are recognizing b prime to be a variable, and b prime is different than just b. It's different than a, it's different than c, and so we actually have one variable, two variables, three variables, four variables in this problem, and we are asked to isolate b prime. So before we can start moving anything around, we actually need to distribute this negative 1. That is a negative 1. And that gives us 5c minus ab prime minus bb prime plus 3ab prime is equal to 0. Again, we're trying to get b prime by itself. The goal here is b prime is equal to something. So at this stage, we take anything with a b prime and we move it to one side and everything else to the other. The fastest way to do this would be to subtract 5c. And in that case, that cancels. I'm now left with negative ab prime minus bb prime plus 3ab prime is equal to negative 5c. Our goal is to get b prime by itself. We'll factor out a b prime. I'm left with negative a minus b plus 3a is equal to negative 5c. Of course, over here, this is all, we factored out a b prime. And so this is b prime times that quantity. Last but not least, we will divide. And so here's our solution for b prime. Now, again, third time in a row, if you had gone the opposite direction, so if you had, from the start, if you had moved this over through addition and this over through addition and this over through addition, and then factored out your b prime and divided, then you would have had the opposite sign for all of these. You would have had positive 5c over positive a plus b minus 3a which again is absolutely equivalent to this. One is not better than the other. They're equal to each other, and they're both correct. That's it.